and thank you very much to give me this opportunity to share our input for 6G. Actually, today we will talk about type of signal which is up to now is under consideration and under development for research, which we call it chaos signal. Chaos signal is well known in control and mechanical engineering, but is still not processed and under research on communication systems. However, today I will try to focus and highlight about the type of chaos signal and the advantage and disadvantage, and if there is any potential which we can use it, which can be used for next communication generation. Although I know that our standard and our traditional communication system for maybe 70 years, 80 years are based on sinusoidal signal. Usually we are talking about spectrum sharing, we are talking about data traffic, we are talking about orthogonality between sine or cosine, but still, if we try to look into the instead of focusing on the hardware, if we can relook into the using of type of carrier rather than using purely sine or cosine, if we try to find some alternative which give us a new look for the spectrum as well, rather than looking for the spectrum as individual frequency, why we can look at the spectrum as a full bandwidth and orthogonal bandwidth. So in general, I can give just let me give us very brief about a chaos signal. Actually, chaos signal is a non-periodic signal. It's random-like. However, it is bounded, not like a noise, it is bounded between two values, like a sinusoidal signal, and can be generated in the deterministic manner. It means that we have a fixed function which can generate it over the time, and we can predict its value over the time as well. However, the periodicity of that chaotic signal is usually cannot directly control unless we are using a specific type of filter. So we can reshape the signal, and we can try to make it very close to the very close to periodic signal. However, let me share some advantage of that. I can say this is the properties of chaotic signal which is known. First is sensitive dependence on initial condition, means like any sine and cosine frequency we can generate it from oscillators. Here we have some generating function which we call it as a generator function, which is generated from map, which is a deterministic equation. Usually is excited by giving an initial condition for the signal itself. However, the beautiful of such signal is you can generate another family or another brother for that signal only by changing initial condition. More interesting is that such type of chaotic signal, the second one is orthogonal to the first one, although they are from the same map. So by giving an initial condition, a new initial condition, we can generate a new family of that signal. However, we can know that for an initial condition, we can have infinite number of initial condition. Theoretically, we can generate infinite number of the signal itself. Actually, it's a pulse-like autocorrelation, similar to the researcher who's working in spread spectrum communication. They are aware of the autocorrelation properties of direct sequence. Chaotic signal itself, if it is correlated with itself only, it can be this. It can give the peaks, which is mentioned on the first graphic here. This is if you are correlating the chaos generating signal with its own self. However, if you will shift that generating signal with one sample, immediately we are ending with very low cross correlation, which is very fit the communication properties, specifically in the detection side. So very low cross correlation properties can be obtained from any flipped version of the signal, delayed version with respect to original one, or permutated version of the signal. So we can generate such a huge number of family signal with only using a single chaotic or single map equation. However, the challenge which we can face on such type of signal is the power spectrum. It is little bit widely spreaded. It does not contain a single frequency. However, it can contain a band of a frequency, which is considered as major challenge of the such type of signal. Simple hardware requirement for such type of signal, we can only use a simple iterative equation, whether we are using a microcontroller to generate such type of signal, or we can use a standard resonator, which is based on differential equation solution. So all these properties of chaotic signal motivate researchers to find an alternative for such communication system. Previously and up to now, within last 15-16 years, all the communication system derived from such type of signal, we can classify it into 3 categories. Some of them are applicable theoretically, some of them are impossible or very difficult to implement. I will explain. The coherent side, we can have a coherent system. Here we can generate our general message and we will be embedded with a carrier. However, to detect it at the receiver side, we need to generate the exactly twin of the first carrier. As we said that the generator or the carrier which is generated in the transmitter can be added with the noise. Here configuration of carrier will be little bit challenging because the receiver side will have a difficulty to identify the chaotic signal, specifically if there is high signal to noise ratio. However, there are many theoretical studies which assume that there is a perfect synchronization between a transmitter and the receiver, and there is now a very aggressive study on using machine learning to detect such type of coherency. A non-coherent signal, here we are embedded the message itself, which we are generated in one of the properties of chaotic signal. This could be in a map, or could be on the amplitude of the chaotic signal, or we can embed the message as a terms of power. We can use 2 chaotic signal to transmit and receive. But again, there is a challenge of detecting such a signal, specifically on optimization of the threshold of the transmitted information bits. But the most interesting one, which I may elaborate more, if using something which we call it as a differential coherent system. And differential coherent system, we can see that we are sending a reference signal. I try to simplify it as I can. We can send the reference signal here. This reference signal is followed by the information bearing signal. The information bearing signal is merely the original signal multiplied by either +1 or -1. This is the first schematic which had been proposed in maybe 15 years ago for using the differential chaos. And the bit error comparison, it's very close, it's somewhere close to the standard communication system. However, the challenge is such scheme is that we are using 2 symbols to represent 1 symbol. So simply I can say that we are losing half of the bandwidth. However, please let us keep in our mind that this is the first chaotic signal which have been investigated. So based on that, there are many developed standard of developed schemes which depends mainly not on the reference signal with the information signal, but recently there is a trend toward using something called, and this is the trend have been erased on the last 3-4 years, 5 years, and using something we call the permutation, specifically when there is a development on the manufacturing of delay line. Here we are sending the reference signal and followed by information bearing signal. In this case, it's a matter of permutation of reference signal. It's a permutation version of the reference signal. However, practically speaking, if we have a very accurate receiver, we can detect, or we can permutate our signal into factorial, or if I am sampling this signal by say 1000, so I can permutate this, my signal is 999 permutation. However, if you can look into this option, this gives a very attractive option as I am using a single reference with a huge number of permutation, but this comes into accuracy of my my processor, and I need to have a very accurate receiver at the inside. However, permutation also can be extended not for one symbol rate, but also can be extended to multiple symbol rate. So I can have a train, or I have a sequence of symbol which can be presented. Here I can stop and I can say that if we have such a type of very stronger processor, why do we think to leave the era of sine and cosine and start focusing on using this kinetic signal to modulate our information? As per my best knowledge, I was trying to figure out if there is any hardware which is using such type of signal, but merely I was able, based on my best knowledge, there is a trial here and there, but there is no uniform effort toward focusing on such type of transmission. And by using this, theoretically speaking, we can have a high bit rate. However, this is, as I said, this is mainly depending on the processor type which we are using. I just put a very simple imagination of how can we, a spectrum of mobile communication, if we are deciding to go for chaotic signal, but I think too late now, but just try to put thoughts between your hands, that if you have a multiple users, and each user can generate a reference signal for him, and these are segments which belong to the first mobile or first users. This will be on the vertical or the time domain, and at the same time I can send multiple, so I can add together all the users at once, and I can add them together on the same time slot, and with very less with multiple access capability and with the minimum interference. Yes, there is a limit of the users, and there are many studies which are focusing on how many users we can accommodate. But again, there is a very limited study on developing such type of communication in hardware side as well. So looking back to the concern of the previous generation of mobile communication, whether G1, G2, G3, G4, also G5, we can see that the main concern is the data traffic, and specifically for the 6G, we are looking for a huge number of IoT devices. We will maybe go for virtual reality and increase the bandwidth, and this is why we start thinking to extend our spectrum to the millimeter region. So, however, no matter how many devices we will be able to use, if we are able to generate initial condition multiple number of signal with only changing the initial condition. We will have yeah.
If
Yes?
you can wrap up in 1 minute, please.
Finished in 1 minute?
Yes, if you can.
Okay, no.
Thank you.
No problem. So, anyhow, massive MIMO, there is also a lot of study for using of chaotic communication in massive MIMO communication. And it is the theoretical study showed that it is very competing with a standard communication signal. Antenna design, there is a poor research on antenna design, and there is a limited study, and mainly depending on using of chaotic on-off keying system. Chaotic on-off keying system, it depends on transmitting a signal into either there is a signal or there is no signal, which is very basic standard. However, there is a limited research on the antenna design of using chaotic communication, and this is mainly due to the bandwidth constraint which are used. Full duplex, it is by default to provide you the full duplex communication. Even if you are using a single carrier, you can go ahead with that.